Here's integrated 3, 10.3.2, lecture part 2. We're on problem 10-155. And it says, Joanna had written a plus b to the fifth as a plus b times a plus b times a plus b times a plus b times a plus b on her paper. When Serene asks, why did you write that? Joanna replies, I thought we could use it as an example. When we expanded a plus b cubed, the expression had a cubed, a squared b, ab squared, and b cubed. What do you think we will end up with for a plus b to the fifth? So I already kind of explained to you guys that there's going to be 6 terms, because on our triangle, row 5 has 1, 2, 3, 4, 5, 6 terms. I'm just going to do the letter, not the numbers, but just the letters. This one's going to have, it's going to start with a to the 5th power, and then it's going to go in descending order. 3, A2, A1, and then A0, okay? And then the B's are going to go in ascending order. So this will be B to the 0, B to the 1, which is just B, B squared, B cubed, B to the 4th, and B to the 5th. And notice that this is the 5th power, and all of these exponents are always going to add up to 5. Like, this was a b to the 0. 5 plus 0 is 5. This is b to the 1. 4 plus 1 is 5. 3 plus 2 is 5. 5, right? 3 plus 2. 2 plus 3 is 5. 1, that's a to the 1, plus 4, that's 5, and a to the 0, 0 plus 5 is 5. Just so you know. And if I wanted to fill in the coefficients, I could grab them off of here, or there's actually another way to put the coefficients in. I'll put them in from here, right? Well, no, I won't. I'll show you the other way. So it says, let's find out what that other way is. So Garth overhears them and says, I've got an idea. Maybe we can look at one of the terms, like a cubed b squared, and look back at the factors to see where it came from. Wait, I think I see it, James chimes in. You just use an a from 3 of the 5 factors and b from the other 2. James continues, counting these combinations is just like what we did in the previous lesson. What counting problem gives the number of ways to choose 3 a's from 5 factors? Well, that would be the combination of 3 things taken 5 at a time. What is the coefficient for a cubed b squared, and how can you figure it out without looking at Pascal's triangle? So if you remember, you filled this whole thing out without any triangle. You filled this out before you knew there was a triangle, and that you filled it out by taking a combination of n things, taking r at a time. And we saw that when we got it all filled out, it was the exact same thing as the triangle. So if you just need a little piece of the triangle and you don't want to draw the whole darn triangle, you can just take the proper combination. So they're saying there's 5 different things, like of the A's and B's, there's 5 factors, and we want to take 3 at a time. So the combination is n factorial, 5 factorial, n minus r, so 5 minus 3 is 2 factorial, and then r factorial. So let's see what that comes out to be. So this would be 5 times 4 times 3 times 2 times 1. This is 2 times 1, and this is 3 times 2 times 1. But the 3 times 2 times 1s cancel out, and the 2 and the 4 cancel out, and I get 10. 10 should be the coefficient that we were looking for when it said a cubed b squared. So they're saying 10 is the coefficient here that goes here. Well, let's see. 1, 5, 10, 10, 5, 1. Yep. So you'll notice these are both 10s. I could have taken the combination of 5 things taken 2 at a time, and I would have gotten the same number, because I could have just said I'm taking the number of A's in this one. Well, it would 2 at a time. There's 2 A's. So that's letter B. And then let's do 10-156. It says, for his homework assignment, Andrew has to expand A plus B to the 9th. He does not know the coefficient for the term A cubed B6. He starts by writing out the 9 rows of Pascal's triangle when his friend Robbie says, just use combinations. What combination should Andrew use, and what is the coefficient of A cubed B6? So I'm looking for A cubed B6. So by the way, if I did, I mean, we can check it right here. Like, we'll check it here, but then you can see that it would take a while to draw this triangle if you don't have one. Just this one was just in my book. But if I was looking for A cubed, remember it goes A9, A8, A7, 6th, 5th, 4th, 3rd. So A cubed should have a coefficient of 84 according to my triangle. So let's see if we can do it with combinations. So there's 9 things, 9 factors. So I want to take the combination of 9 things taken 3 at a time. But we saw in the last problem, I also could take the combination of 9 things taken 6 at a time, and because that kind of works for the B's, but that's going to be the same exact number. It's still going to give me the 84. Well, let's hope it gives us the 84, right? So it's n factorial, and then this is n minus r, 9 minus 3 factorial, and then this is r factorial. And you should just do all that math and you get the 84. Okay, one more before I run out of time. So this is 10-157, the last one we're going to do. Rebecca needs to write the 5th term and the expansion of A plus B to the 11th. I need the 5th term. Oh, what's the 5th term? Oh, well, I guess I only need the 5th term. So I know that the A's are going to go in descending order. So it'll go like A to the 11th, A to the 10th, 9th, 8th, 7th. So it's going to have A to the 7th. So the 5th term is going to have A to the 7th. And remember, I told you that the A's and the B's, the little exponents, have to add up to whatever that number is. So this will be B to the 4th. But I don't know the number part, like the coefficient. So I'm going to have to use a combination. So I'll use the combination of 11 things taken 7 at a time. Why 7? Because I want 7 A's. I could do the 11, choose 4, either way. So remember, it's n factorial, so it's 11 factorial, and then it's n minus r, so that's 11 minus that's 4 factorial, and then 7 factorial. And I'm lazy, so I'm going to go 11 times 10 times 9 times 8, but I don't want to do the 7, 6, 5, 4, 3, 2, 1, because it's just going to cancel with that. And then this will be 4 times 3 times 2 times 1. So the 4 times 2 can get rid of the 8, and then the 3 can make the 9 turn into a 3. And then I have 30 times 11 is 330. So is that right? Yeah. So that's 330. So this is part of the answer for 11-157. They wanted the fifth term, so there it is. Use some combinations to get it. Now Rebecca needs to know the fifth term in the expansion x minus 2 to the 11th. How can you use the result from part B to help Rebecca with her problem? Okay, so it's x minus 2 to the 11th. So I know they want the fifth term. So they still want the fifth term, so that's good. I know it's going to be 330 times x. So what I'm doing is I'm saying that let's let x equal a, and then let's let b equal -2. See? So if x is a, it's x to the 7th. And then b, well, that's -2 to the 7th. No, it's not 2 to the 7th. It's -2 to the 4th. And I think I just do that. And then -2 times -2 times -2 times -2. That would be 16. 330. Okay, so that's 5,280. That's what this times this equals, times x to the 7th. Let's check and make sure. Yeah, that's right. Okay, so I'm going to let you do the rest on your own. Good luck.